Friends, today's topic is method to find the range of a function y is equal to fx. Friends, first of all, find the domain of y is equal to fx. Okay, the given function is y is equal to fx. So first of all, we shall find the domain of this function. Next step is, if domain is a set having only finite number of points. Okay, what is this? If the domain is a set having only a finite number of points, then you can find the range in this way. Range is the set of corresponding fx values. Okay, just find the fx values corresponding to the given domain value, so you will get the range. And the second one is, if domain of y is equal to fx is r means minus infinity to positive infinity, or r minus some finite number of points, or an infinite interval. Infinite interval means r, that means minus infinity to positive infinity. In this case, express x in terms of y. Okay, express x in terms of y. Find y for x to be defined or real. Apply the condition for real roots. Okay, next, third point is, if domain is not an infinite interval, the domain is not an infinite interval. Okay, in this case, find the least and greatest values of fx using monotonicity. What is monotonicity? The method and the facts are discussed in the previous video. Please visit the previous video. The links are given in the description. Okay, first of all, we shall study the first example. Our first example is, find the range of y is equal to x square divided by 1 plus x square. Okay, now friends, this y is defined for all x belongs to R. For all x belongs to R. Hence, R is the domain. Okay, again I repeat, y is defined for all x belongs to R. So whatever you get from the set of real numbers, you put it here, so you will get a value of y. So R is the domain of this given function. Now, from y is equal to x square by 1 plus x square, friends, we have x square y plus y is equal to x square, so that x square is equal to y divided by 1 minus y. Okay, that means you are getting x is equal to either positive root over y by 1 minus y, or negative root over y divided by 1 minus y. So in either case, for x to be defined, this is obvious that y by 1 minus y should be greater than or equal to 0. That is, y divided by 1 minus y is greater than or equal to 0. Now friends, y divided by 1 minus y. Okay, so we shall use the sign scheme. That is 1, y minus 1 divided by, y minus 0 divided by minus of y minus 1 is greater than or equal to 0, or y by y minus 1 is less than or equal to 0. So we draw a line. This is negative infinity to positive infinity. Critical points are respectively 0 and 1. So this is 0 and 1. This one is positive. 1 is the critical point. So factor is y minus 1. Its power is 1. 1 is an odd number. For this, you have to change the sign. And for the critical point 0, the factor is y minus 0. Its power is also 1. 1 is another odd number. For this, you have to change again the sign. So this is positive. Now friends, since the inequality sign is less than given, so you have to choose this part. Okay, this part. So that means from 0 to 1. So friends, the range is, now we can say the range is from 0 to 1. 0 is closed but 1 should be opened, because if you put y is equal to 1, y is equal to 1, then 1 minus 1 is equal to 0. For this, y by 0 is undefined. For this, you have to discard this 1. So only the range will be from 0 to 1. Okay? We shall see the next video. Friends, find the domain and range of the function y is equal to log of 3x square minus 4x plus 5. The base is given e. Now this y is defined if 3x square minus 4x plus 5 is greater than 0. Again I say, y is equal to log of 3x square minus 4x plus 5. This function is defined only when 3x square minus 4x plus 5 should be greater than 0. Now friends, what is the discriminant of this polynomial? The discriminant is equal to minus 4 whole square minus 4 into 3 into 5, that is 16 minus 60. So this is equal to minus 44, which is less than 0. And also another thing is very important. What is the leading coefficient of this polynomial? The leading coefficient is 3, positive 3. So since the coefficient is positive and the discriminant is less than 0, for this, the curve of this function, it will not touch the x-axis and will be on the upward direction. Okay, so the function is always positive. The function is always positive. 3x square minus 4x plus 5. This polynomial function gives you positive value. So friend, we can write 3x square minus 4x plus 5 is always greater than 0 for all x belongs to R. Okay. So friends, its domain is R. The domain is R. Now we shall represent y in this way. Y is equal to log of 3x square minus 4x plus 5. The base is e. Use the definition of logarithm. So we can write here 3x square minus 4x plus 5 is equal to e to the power y, or 3x square minus 4x plus 5 minus e to the power y is equal to 0. So this is a quadratic form. Okay, since x is real, so its discriminant should be greater than or equal to 0. That means from this one we get 4 square, that is negative 4 whole square minus 4 into 3 into 5 minus e to the power y is greater than or equal to 0. That is 16 minus 60 plus 12 e to the power y is greater than or equal to 0. Implied that 12 e to the power y is greater than or equal to 44. That implies e to the power y is greater than or equal to 11 by 3. So take log to both sides, you will find y is greater than or equal to log of 11 by 3. So friends, carefully see, y is greater than or equal to log of 11 by 3. That means its range is, the range is semi-closed interval log of 11 by 3 comma infinity. Okay, this is the range. Thank you. Have a nice day.